So I'm Chuck Willis. This is Willis and Belani. This talk, if you're not in the right place, you're going to know, because the title of this is Web Application, Incident Response, and Forensics. And Rohit really likes the subtitle there, that it's a whole new ballgame. So we're going to be talking a lot about how this is different from your traditional incident response and forensics procedures, and especially the kind of things that we've seen in doing these sort of incident responses. So we'll move on. So we're from Mandiant. This is just a quick overview of our company. We're basically a full spectrum information security company based in Alexandria. We've also got a New York City office. But we do primarily incident response, forensics, application assessments. We have some software, free software right now, so go on our website and grab that. So we kind of do the whole gamut of things. If you guys were in the previous talk, you heard Kevin Mandia, our president, speaking about his experiences in incident response. So that's the one slide marketing pitch. And now we're going to talk about why we're here. So this is really what we've heard is that you hear lots of people saying that web application attacks are on the rise. Gartner is always doing studies about the different types of attacks that are out there, and a lot of them are not very scientific. It's very hard to quantify, especially when you start looking at exploits and vulnerabilities that are discovered. You'll see a lot of them in the common web applications, but what's very hard to quantify is custom code that always has all sorts of vulnerabilities in it as well. So that's what they say, but what we've seen is that 70% of the intrusions and other incidents that we've responded to at Mandiant in the last year have been some sort of web application related incident. So what we really identified is that our standard forensics and incident response procedures were not working. So we wanted to look at how we could respond to these incidents and how to try to guide you guys along the same, basically the same path. So we will, so that's why we're here. This is the agenda real quick, and I just want to caveat this at first with, we're going to rush through the background and some of the other more detailed slides pretty quickly, because I think you guys are more interested in the actual case studies and that we're going to be talking about. Real incidents that we've responded to that have had details changed in order to protect our clients and all that kind of thing. But we've got just the real world case studies, I think, are what's most interesting. And so, like I said, later on we're going to get to some detailed slides about logs and where different servers store logs. We may rush through those, especially in the interest of time. But those are definitely for your reference to go back to later when you go to respond to an incident. And we're also going to touch a little bit on, once you've done all this stuff, how you actually fix the problem, the remediation that needs to be done. So that's where we're going. And with that being said, I'm glad to see people are still coming in and no one's leaving. So I guess you guys are interested in this stuff. So a couple quick slides on background. The first one is just, this is a web application. So you guys can all see that, right? That's not getting cut off at the sides or anything. You can see the whole slides? Okay. If there's any problems, let me know. But this is a typical web application in the sense of this is kind of the stereotypical model that everyone follows. You've got your client web browser over here that I hopefully can point to. You've got the internet, stuff goes to the internet, HTTP. You've got your web server, that's kind of the front end. You've got an application server that's behind that, and then you've got a database in the very back. And those could be 3 physical servers. They could be all on one server. There could be, especially at the database cluster, there could be a bunch of systems back here at the database level, a cluster of them. At the web server level, sometimes you'll have web server farms and various other stuff in front of the web server, sometimes SSL accelerators and load balancers, that kind of stuff. So that's the one-page web application class. So now we're going to talk a little bit about just the standard incident response and forensics. So this is the stuff that has been taught for a long time as far as how you go about conducting your incident response. And basically, when you come across a system that you think's been compromised, you're going to capture some volatile data, stuff that's going to go away when you shut the system down. You're going to grab process lists, ports, the memory dumps, as far as both the entire physical memory and individual processes sometimes. You want to know who's logged in, that kind of thing. And you may capture some non-volatile data that you just want to have in a more easily accessible form, like the event logs, time, date stamps, that kind of thing. And then after you've done all that, you basically shut the system down, you run it through something like Ncase where you're imaging the entire hard drive, and then you dump that image into the end case analysis portion that will then analyze the system, look at the file timestamps. You're going to be looking for strings in various places. You may check for known malicious software using like antivirus or that kind of thing. So that's kind of the standard incident response and forensics process. So how do web applications differ? Well, that's basically the subject of this talk, but we're going to have kind of a one-page summary here after we talk about why we can't just do what we normally do. Why can't we just go out and do our imaging and all that? Well, unfortunately, as we saw in the earlier slide, web applications are split across different servers. So you've got that to worry about. You can't just image one server. You've got to image 3, perhaps. But the more critical issue is that, especially when you're looking at databases that have huge disk arrays, it takes a long time to image them. And in order to image them, you've got to take them offline. And when you take them offline, the business isn't making money. Presuming that the web application is there to support some sort of business process that makes the business money, because normally it wouldn't be there otherwise. So that's an issue. And then you also have the issue of, even if you can do all that and do your traditional forensics, you're not looking for the same things. If you've got a web application intrusion, you're not going to see typically stuff in the event logs or in those kind of places that you look. You're not going to see time and date stamp on files typically as being significant. You're going to be looking for things within the database and within the applications. So that's really what it comes down to. You've got to understand how it is that web applications work and understand web application security issues. And that's what we're here to talk about. So this is really kind of the overview. The very first step is what I just mentioned. You want to understand how the application works and how you can go about, how it normally moves data around and handles sessions and those kind of things. One of the things you're going to be spending a lot of time on is really just looking at log files. You're going to be looking at the web server, application servers, all the other server logs to try to figure out what exactly happened as far as when the system was, when someone came in. And you're going to be basically trying to identify anomalies. And looking at both that and also in the source code is part of it as well that we'll talk about later. And this is the kind of anomalies you're going to be looking for is, typically you're going to have, some sort of malicious input filtering that's broken. The application may be logging that. You may have weird refers or session issues and that kind of thing. So that's basically how it goes. And once you've identified that, then you kind of know, okay, this is how they came in. And then you can basically go back and say, now this is when they came in and what they did, hopefully. And then you can determine your remediation plan as far as what you're going to do about it now. So that's the one slide overview of this talk. So now I'm going to pass it over to Rohit, who's going to talk about a case study from something that we've seen.
Hey, how's it going? So I guess the first case I'm going to talk about is something that we dealt with again earlier this year. You look at the title up there, it says symptoms. And like Kevin mentioned, we rarely go into an organization and where we're told exactly what happened. We wouldn't be there if that was the case. So when we walked in, we're not told, and sir, I'm suffering from mononucleosis due to streptococcus bacteria in my pharynx. That doesn't happen. It's more something like I got a throat ache. We have to kind of figure out what happened from there. So if you look up the slide there, this is the symptom that we walked into. All we were told is, I saw a trade executed from my account. 10,000 shares of a company I've never heard of were actually purchased using my bank, or rather my brokerage account. It happened on January 17th at approximately 2 p.m. is what the alerts show me in my online profile, and that's all about I know. Well, 7 other clients of that brokerage firm, people like you and me who use web-based brokerage firms, reported the exact same incident. So 8 people were reporting the incident. Anyone want to tell me what the cause might be here just looking at this particular scenario? Well, these guys are home-based users. They're all probably different people. But one point was right. It probably was a keystroke logger. That's the first thing that comes to mind when an end user's hacked. Chuck's ready with the T-shirt. He's a bad thrower. Oh, God.
Almost made it.
So 8 people reported this incident. What was interesting, and I'll give away the story before I even get into it, there were thousands more who were affected by this exact same incident. But none of the other guys reported it. Why? I'm sorry? Embarrassment. Didn't notice it. Oh, who said that? That was the answer. I got to come and give you a personal invitation to our cocktail party. You are great. The stock went up was what the reason was. So the stock goes up, people make money out of these trades. Obviously, they're not going to report it to the authorities. Make hay while the sun shines. So we walk into this scenario. Well, obviously coming in as computer experts, we look at two different aspects. It could be the web application or the infrastructure at the brokerage firm that might have been hacked, or it could be the end users, keystroke loggers, other forms of malware that are on the system. We didn't know what was going on. All we knew was 17th January 2006 at approximately 2 p.m. something happened. Shit happened. That being said, we kind of split our team up into two and said, well, you guys go look at the infrastructure for the brokerage firm, and you guys go look at the end user machines. So the guys who started looking at the end user systems were obviously looking for malware, but the other guys had to understand how the web application operated, what possible logs they could get their hands on, network logs, firewall logs, etc., etc. It was a long process. As part of the process, we received IIS logs for 17 January 2006 from all the load balance servers. You can imagine on a brokerage firm, those log sizes can be pretty large, especially trades around 9 a.m. in the morning, 9:30 a.m. in the morning, 4 p.m. fill those logs up pretty quick. We came out with 1 gig of log files. There was no easy way to manually look through them. Fortunately, in this case, a Microsoft software came to the rescue, log parser. Log parser, just to give you a little bit of background, is a pretty good tool to analyze log files, especially if they're Microsoft log files. And it allows you to use SQL syntax to actually peruse these files pretty easily and trim them down to sizes that are more manageable. So what did we want to do first? Actually, let me go back and ask the question. For those with keen observation powers who looked at that slide for 1.5 seconds, what would you want to look for when you walked into this scenario? If you were the guy looking at the brokerage firm's infrastructure and application, all we knew was malicious trades were executed on a particular day at a particular time. I'm sorry? Internal attack. But okay, let me rephrase. From the particular date, the particular time. Look for the particular date, particular time. Definitely want to do that, yes. And the stock. And the stock. Right, if it was a part of the get parameter, if it was a get parameter that was passed as a part of the URL, we definitely want to look through the log file looking for that particular ticker symbol. But even before that, we said, well, let's just look at all the executions that happened, all the trade executions that happened on that particular day around that time. So we ran a query using log parser, said, let's just select all execute.asp requests that happened on that particular day and dump them in a CSV file that allows us to sort it pretty easily using Excel. Having done that, obviously, we had an overwhelming number of responses that came back. Here's an abridged version of the log file. Again, it's been sanitized for obvious reasons. What you see there is not nearly as detailed as what we were having to deal with. But now start my barrage of questions. Having looked at that, help me solve this case. What do you think is the problem here? Can everyone read the... Ooh, I heard session IDs times, yada. Source IPs are related. So you see that one particular source IP address repeated several times. Someone said session ID. Who was that? Session IDs. What about the session IDs? The session IDs are the same. Anything else you see there? I'm sorry? Different IPs using same session ID. Is that accurate?
Yes.
Yes, that is accurate, actually. What else do you see there? HTTP version 1. HTTP